We're starting in section 24.4 of the Tech Math book, and we have the fundamental theorem of the calculus, which is something that we don't worry about because we're technology guys, but if you were in a regular calculus class, you'd spend a couple weeks proving this. And it says the integral from a to b of f of x is going to be f at b minus f at a, where f prime of x is f of x. And we better throw a dx in there just to make everybody happy. The shorthand we're going to do is integral a to b f of x dx is equal to f of x evaluated at a and b. So that's how we write that as shorthand, but that's what we're doing. Now, if I look at that and I say, well, when I take a regular integral, I go integral f of x dx, I end up with f of x plus some constant of integration. Well, when I'm doing a definite integral, I have plus the constant of integration plus the constant of integration, which is subtracted away, and that's why it's not there. So that's why it doesn't show up. Okay, enough of that. And I guess we're ready for problems. And our first problem is number 10. Integral 8 to 27. Is that what it really says? 5x to the 3 2/3. Plus 4x to the minus 1/4. No, minus 1/3. Okay, now we remember that the integral of x to the n is x to the n plus 1 divided by n plus 1. So that's all we're going to do. And we're going to say that this is equal to 5x. I add 1 to that and I get 5/3 divided by 5/3 plus 4x. I add 1 to that and I'd end up with 2/3 divided by 2/3 evaluated at 8 and 27. And then I'd rewrite it as the 5's go away, and I'd have x to the 5/3 over 3 plus 2x to the 2/3 over 3 evaluated at 8 and 27. Okay, so I throw in the 27 first. X 27 learning disability. 27 raised to the 5/3 divided by 3 plus 2 times 27 to the 2/3 over 3 minus 8 to the 5/3 over 3 plus 2 to the 2 times 8 to the 2/3 over 3. Alright, so that's what I have. Now at any moment we could just put it in our calculator and solve it, right? That would be a reasonable thing to do. The cube root of 27 is 3. 3 divided by 3, 3 divided by 3 would be, well, we can't do that yet. So 3 to the 5th would be whatever 3 to the 5th is. Divided by 3 would be 3 to the 4th. So that would give us 81. So this guy's 81 plus, doing the same thing, 9 divided by 3 is 3 plus 6 minus. The third root of 8 is 2, 2 to the fifth is 32, so it'd be 32 over 3 plus 4, 8 over 3, 8 over 3, 87 minus 40 over 3, 40 over 3, and 13 and a third. So it'd be, I subtract away 13, and I have 74. So 70, that doesn't look like a 7 to me. 73 and 2/3. And at that point, we take out our calculator and move back up to some reasonable spot in the program, in the problem. All right, so 27 raised to the 5/3 divided by 3 plus 2 times 27 raised to the 2/3 divided by 3 minus 8 raised to the 5/3 divided by 3 minus 2 times 8 raised to the 2/3 divided by 3. Now, assuming that I put that in my calculator right, I get 73 and 2/3. Is that what I said my answer was? Yeah, so that it checks with that far up in the problem. Okay, well that seems like a reasonable thing to do. So I would probably have grabbed my calculator earlier in the process, but I couldn't grab it until I got to that point. That's probably where I would have to grab it for. Okay, now we're looking at problem number 14. Okay, so I've got integral from 0 to 1, 2x plus 1 raised to the 5th dx. All right, so I'm going to go and I'm going to make a guess. I'm going to guess I'm in the form 2x plus 1 to the 6th. And if I take the derivative of that, I'm going to have 6, 2x plus 1 times 2. So I need a 12 here and a 1/12 on the outside. And then I'm going to have 1/12 2x plus 1 raised to the 6th power, evaluated at 0 and 1. Okay, so that's what I'm doing. 1/12. I put in a 1 and I get 3 to the 6th. 3 to the 6th. Well, I don't really know what that is. I put in a 0 and I get a minus 1. So 3 to the 6th minus 1 divided by 12. 3 raised to the 6th minus 1 equals, divided by, that's 728 if anybody wanted to know, divided by 12, and I get 60 and 2/3. Now, because I forgot, but my calculator does this automatically, right? So I could go to second function interval, 0 to 1, and I could put in 2 times x plus 1 raised to the 5th and you just hit my enter button, and it'll give me an answer of 60 2/3. So my calculator would have given me an answer of 60 2/3. And if I go back to the first problem, I can do the same thing. So I'm going to go second function, integral 8 to 27 of 5 times x raised to the 2/3 plus 4 times x raised to the minus 1/3, close parentheses, syntax error. Darn, I entered it wrong. Okay, so we won't go back to that one if I'm going to enter it wrong. All right, but I'm sure it'd come out that way. Next problem is 24. Integral minus 1 to 1. 16x over the cube root of (3x squared plus 5). Well, I guess what we'll do is we'll put it in my calculator first and see if it'll give me an answer. So I'm going from minus 1 to 1 of 16 times x divided by, with parentheses, 3 times x squared plus 5, close parentheses. I don't have enough parentheses. Bummer. See if it lets me insert one. Insert parentheses. Okay, there. So I got another set of parentheses, so that's good. That was probably my problem the last time. I didn't have enough parentheses. Raised to the minus 1/3. Okay. That looks right. No, that doesn't look right. Oh, I need another set of parentheses. Insert parentheses. All right, now that looks right. Boom. Syntax error. Oh, stupid machine. All right, enough of that. So I'm going to guess that my answer is 3x squared plus 5 to the 2/3. When I take the derivative, I'm going to get 2/3 3x squared plus 5 to the minus 1/3 times 6x. 6 goes into 3. 3 goes into 6 twice. I have a 4 there. I'm supposed to have an 8. So what I'm going to do is I'm going to put a I have a 4 there and I really have a 16. So I'm going to put an 8 out here and a 4 there. That was brilliant, wasn't it? Because that wouldn't work. I'm going to put a 4 in both places. So I'm going to put a 4 there, a 4 there. That makes that 16. And I'm supposed to have a 4. Okay, so that being the case, 4 times 3x squared plus 5 raised to the 2/3, evaluated at minus 1 and 1. Four times, I put in a 1. 3 plus 5 is 8. The cube root of 8 is 2. 2 squared is 4. Minus. I put in a minus 1 in, and I square it, and I get the same thing. and then I end up with this thing being 0. Now, could I have predicted that by just looking at the problem? I'm not so sure. Let's put a graph in Maple of this problem. If it's an even guy, then I expect the same below and above, and it should be 0. Graph assistance plotter. Okay, so I want to add something. What do I want to add? 16x y. Y, where's y? Y equals 16x divided by 3x squared, 3x squared plus 5 raised to the minus 1/3 minus 1/3. Is that the whole thing? That must be the whole thing. Invalid expression. Oh, need another parenthesis. That's not a parenthesis. Invalid expression. Okay. See if it likes that one better. There we go. Is that right? Yeah, that'd be right. Plus 1/3 would be on the top if it were minus 1/3. But why didn't it write it that way? Interesting. All right. We want to go plus and minus 1, right? So we just go plus and minus 1. Minus 1 plus 1. And how big does this thing get? Not very big, right? Yeah, it doesn't get very big. All right, so we'll just plot that. And we see that when we go plus or minus 1, we have just as much below as we do above the x-axis. And that's why it did what it did. Now, how come it only went to... Oh, I see. We needed more. We needed probably plus or minus 100 on the y-axis. Okay. Goofing off enough with that already? All right, so 24 is probably right. All right, we're now in section 25.1. But it would have been nice if our calculator would have given us that answer. Area between two curves. All right, so if I have two curves, I can find the area between the curves. All I have to do is go integral a to b f of x minus the two curves dx, and what I have to do is figure out if that's f of x, and if this guy is g of x, then I'd have, if I wanted the area between the two curves, I'd have to figure out what my limits are of my integral. So if if I could figure out that point and that point, then I could put them in A and B. F of x being the guy on top, g of x being the guy on the bottom. I subtract them, and I'm going to find the area. So that's the theory involved. I'm going to start with number 10. And we have y is x squared, y squared is x, 4x, y squared is 4x, and that's all we have. Okay, well,
You messed up the top one. It's 2x squared.
2x squared. Okay, so we're going to make a better than normal graph. This guy we're going to change to y is equal to plus or minus 2 the square root of x. Okay, so we're going to change him that way. All right, so this guy here, if I'm at 0, if I'm at 0, I'm at 0. If I'm at 1, I'm going to be at 2. And if I'm plus or minus 2, then I'm going to be at 8. Okay, so that's what that graph looks like, something like that. Now, plus or minus the square root of 2. So if I'm 0, I'm going to be at 0. If I'm at 1, I'm going to be at 2. So this guy's going to do something like that. Now, I can't use negative x's, so the other guy's going to do something like that. So I'm looking at that area there is what I'm looking at. Okay, so I'm looking at integral from 0 to 1, 0 to 1 of 2 the square root of x minus 2x squared, I think, dx. Alright, well, let's see if I can do that in this guy. Integral from 0 to 1 of 2 times the square root of x minus 2 times x squared appears to be working. Oh, I got an hourglass. And it says the answer is 2/3. 2/3. Okay, well, let's see if we can get 2/3. And I look up here and yeah, why not 2/3? Yeah. So I got this is going to be integral 0 to 1, 2x to the 1/2 minus 2x to the squared dx. So I'm going to have 2x to the 3/2 divided by 3/2 minus 2x cubed divided by 3, evaluated at 0 and 1. When I put in a 0, everything's going to be 0, so that's good. So when I put in the 1, I'm going to have 4/3 minus 2/3, which is 2/3, and that's a big green check. But the key was, until I figured out the limits of integration, who was on top, I couldn't do it at all. So that was the key to the problem. 10 going to 15. Now 15 and 25 are dangerous problems to do because the answer's in the back of the book and I could look bad if I got it wrong, right? Alright, so I've got x is equal to y plus 1, and I've got x is equal to 3 minus y squared. X is equal to 3 minus y squared. So I'm going to rewrite this guy, y is equal to x minus 1, and I'm going to rewrite this guy, I'm just going to leave that guy the way he is probably. Y is equal to plus or minus the square root of 3 minus x. Okay, so now I look at that and I say, that guy, there's minus 1, and I have a straight line, and there's 1. Now, this guy, when x is 0, y is the square root of 3. Okay, so x is 0, y is the square root of 3. Now if we rewrite this as y squared is equal to x, 3 minus x, right? 3 minus x. It looks to me, if x were 3, y would be 0 right there. And then this guy's going to do something like this, like that. Yeah, so now I have to find that spot and that spot is what I'm looking for, because that would be the area between the curve. Okay, so that's what I'm doing. Okay, so when is y plus 1 equal to 3 minus 2y squared? When does that happen? Okay, so I got y squared plus y minus 2 is equal to 0. Okay, and I'm going to factor that y plus 2 y minus 1 is equal to 0. So that happens when y is 1 and when y is minus 2. Okay, so that's where those 2 points are. Now, how in the world Alright, so when y is 1, what is x? X is 2, so that's a 2. Alright, so it would appear that I have something that looks like this, like that. I can get this part easily. That's just that guy minus this. But how do I get that part out there? How do I get the part between 2 and 3? That would be the issue. Okay, so I got 2 different integrals to do. I'm going to go, that's 2. What is this guy? When y is minus 2, what's x? Y is minus 2, x is minus 1. So this guy happens at minus 1. So I can go integral minus 1 to 2 of the guy on top, which is y, which is the guy on top, x minus 1. X minus 1 minus the guy on the bottom. And the guy on the bottom is going to be minus the square root of 3 minus x. Minus the square root of 3 minus x. Okay, dx. Okay, so that's that part. Then we have to consider how are we getting that part. Well, that part is the same here as it is there, right? So we could go plus integral 2 to 3, and it'd be 2 times that, because we want the guy on the top and the bottom, of square root 3 minus x dx. All right, so that's how we would do it. We would do the part where one's on top of the other first, and then we get that part second. So that's our plan. All right, so I've got integral minus 1 to 2 x minus 1 plus square root of 3 minus x dx plus 2 integral 2 to 3 square root of 3 minus x dx. Well, that looks like what we have to do. All right, so I got a guess. 3 minus x to the 2/3 y prime to the, not 2/3, 3 halves. I take the derivative and I get 3 halves square root of 3 minus x minus 1. Okay, so I'm running out of room. So I'm going to go integral minus 1 to 2 x minus 1 dx plus integral minus 1 to 2 of the square root of 3 minus x dx plus 2 the integral of 2 to 3 square root of 3 minus x dx. All right, so that's what I'm doing, but I'm breaking up this integral to do the parts that I can do easily. And then I know that this has to be, I need a, in order for that to be the answer, I need a minus 3 halves there, and I need a minus 2/3 on the outside so that they cancel out to get what I had before. Okay, so over here I need a minus 3 halves, and I need to multiply by minus 2/3. Okay, now I'm ready to do integrals. So I've got x squared over 2 minus x, evaluated at minus 1 and 2, minus 2/3 3 minus x to the 3 halves, evaluated at minus 1 and 2, plus minus 4/3 3 minus x to the 3 halves, evaluated at 2 and 3. Okay, so parentheses in there. I put a 2 in. 2 squared, 4, divided by 2 is 2. So I have 2 minus 2 minus 1/2 plus 1 minus 2 over 3 times. I put a 2 in, I get a 1, so I get a 1. I put a minus 1 in, I get a 4. 4, that's an 8. So it'd be minus 8. Okay, I can do the same thing here. I'm going to get the same thing. So I'm going to minus 4/3 times 1 minus 8. Alright. So the 2 and 2 cancels out. I got minus 1/2. I've got a 7. Minus 7 plus 7 plus 14/3. Minus 7 plus 7, 28/3. Grab my calculator. Minus 1.5 plus 14 over 3 plus 28 over 3 equals 12.5. Am I close? No one looked yet? Is it the book has 9 over 2? Doesn't that just piss you off? Stupid book. Huh? You sure? Huh?
Book must be wrong then.
Well, that's pretty close. So I wonder where the mistake is. Yeah, let's see if we can see it. Okay, well, that's true. This is true. Our equation seems to be right. We seem to have the areas of limit of integration correct. Why do I have 2 minus signs here? Okay, I have 2 minus signs there, so it becomes a positive, and it's a positive because I'm taking the negative part of that guy. Okay, that's fine. And it becomes positive here, and it becomes positive there. Two-thirds 1. So I need a minus 2/3. Minus 2/3 minus 3/2. Minus 3/2 plus 3/2 gives me that. Okay, I'm doing the same thing there. Okay, x squared over 2 minus x, blah blah, minus 3 over 2 times that guy, minus 1 and 2, 4 over 3, 3/2. Okay, that's the problem right here. This goes minus 1 to 2, that goes 2 to 3, and that's not what I did. Okay, so 3 minus 3 is 0. 2 3 minus 2 is 1. Is 1. So this is a positive 1. Okay, so this is not 28/3. This is a negative 4/3. Minus 1.5 plus 14 thirds minus 4 thirds equals, it looks like 1 5/3, and that's not what you told me I had, right? 9 thirds, is that what you told me I had? Huh? 9 halves? I don't have 9 halves yet. I have 9 thirds. Alright, so if the author says 9, actually I have 8 halves, right? I have 8 halves. 3. I put a 3 in there, I get a 0. I put a 2 in there, and I get a 1, right? But it's a minus 1. So because it's a minus 1, this becomes positive. That's positive. So now I've got 18 thirds minus 1 1/2. 18 thirds is 6, right? 6 minus 1 1/2 would be 4 1/2, 4.5. There, we got it. Click. 9 halves. So we won't disagree with the author. We'll just do the arithmetic right. Okay, so it's the upper guy minus the lower limit, and I didn't have the minus the lower limit. One more, and then we go away. Number 25. Number 25. Now, clearly that last problem would have been better off if we were using a big piece of paper that we started way on the top. And 25 is probably the same way. Okay, so I've got y is equal to x minus 1, x minus 2, and the x-axis, x minus 3, and the x-axis. Okay, now this is going to go through 0 at 0, through 0 at 1, through 0 at 3. Okay? And between 0 and 1, between 0 and 1, it's going to be negative, and between 1 and 3, no, between 1 and 3, between 0 and 1 it's going to be positive, between 1 and 3 it's going to be negative, and then above 3 it's going to just keep going high, and below 0 it's just going to keep going low. Okay, so it looks like what we're looking for is this area and that area, and we probably want this area as a positive number and that area is a positive number, is probably what we're looking for. Alright, so we're going to change, we're going to multiply this guy out. So y is equal to x cubed minus 4x squared plus 3. Okay, so we're going to look at the integral 0 to 1 of x cubed minus 4x squared plus 3. And then we're going to go minus the area 1 to 3 of x cubed minus 4x squared plus 3. And that's going to make this guy, that's going to be positive. This is going to be a negative number, which is making a minus, it makes it positive, and then we'll get that total area, which I think is what the author is looking for. If not, we'll reconsider later. Okay, so I got x to the fourth divided by 4 minus 4x cubed divided by 3 plus 3x evaluated at 0 and 1 minus x to the fourth over 4 minus 4x cubed over 3 plus 3x evaluated at 1 and 3. So that's what we're looking for. I put in a 1 and I get 1/4 minus 4/3 plus 3 minus the 0 guy, everything goes away, minus, I put in the 3, 81/4 minus, anybody know what 27 times 4 is? 108. Minus 108 over 3 plus 9 minus, I put in a 1/4 minus 4/3 plus 3. Okay, so that looks like what we're looking for. 1/4 minus 4, wrong button, 1/4 minus 4/3 plus 3. You gotta be kidding me. I'm gonna change my mode to, I'm gonna change it to classic mode. There, maybe that'll work. Okay, 1/4 minus 4/3 plus 3. No, change my mode. It's in fixed. We want it to be floating. We want, why doesn't it give a math print? Should give us math print. Boom. All right, 1/4 minus 4/3 plus 3. Why isn't it giving me to it as a fraction? And this stupid calculator won't convert easily back to a fraction. It's got to be a mode thing. Normal, engineering, floating point, real. 1/4 minus 4/3 plus 3. Still doing it. Is it 1/12? 1/12. Is it 23/12? Yeah, 23/12. Okay, so this is 23/12 minus, okay, 81 quarters minus 108 thirds plus 9. So I find this hard to believe. Minus 6 3/4. Yeah, I guess it could be. Okay. Minus this number, which is the same as that number, 23/12. Alright, so I got 23/12 plus 23/12 plus 6 3/4. I got a 10.5833 repeating. That's probably 5 12s. 10 and 5 12s. No, it isn't. It's not 10 and 5 12s. It's 10 and 7 12s. 10 and 7 12s. Yes. So is that, am I close? 10 and 7 12s.
37 12s or 3 and 1 12.
So I'm only supposed to have 3 and 1 12th. And I got 10 and 7 12s. Okay, so now we got to go back and reconsider. Is it a negative number the book's giving us? No?
Nope.
No, not a negative number. Okay, so that means both of these guys are probably positive again. 1 and 3, 1 and 3. Okay, I did this guy right. I put a 3 in there. 3 to the 4th is 81, right? Yeah. And that's right. 3 times 3 is 9. Minus, I put in a 1. 1 4/3, 3. Minus, minus, minus. 81 quarters minus 108 thirds plus 9. It says it's minus 6 and 2/3, 6 and 3/4. That's what it says. That's got to be negative. That's got to be negative. Okay, let's look at the graph. See what we're seeing wrong. So y equals x times x minus 1 times x minus 3. That's the right guy, right? Okay, so that's the right guy. We're going to go from minus 1 to 5. And how high should we go? Plus or minus 10? We'll go plus or minus 10. That should be funny. Plot. Come on, not coming down. All right, so that's exactly what I said it was. Now, the book says the answer is what?
37 12.
3 and 7 12s?
37.
Hmm?
37.
37 12s. So some number less than 3, right? And that's what it looks like. It looks like some number less than 3 from the graph. Because if I go and I put a thing that goes like that and like that, then that'd be 2 times 3, which would be 6. But I don't have all that. So some number less than 3 is probably correct. So our number is clearly totally and completely hosed. So now, but I am correct 1 to 3 and 0 to 1 and 1 to 3. I got those guys right. All right, so moving back. Did I do this wrong? X squared minus 4x plus 3. No, I did that guy right. Did I do this wrong? No, no, no. Did that guy right. Now, if I were to say plus here instead of minus, then I'd get a minus 6 3/4. So I can't do that. That's not where the mistake is. As I put in a 1, put in a 1, put in a 1. Put in a 0, they all go away. I put in a 3, I put in a 3, I put in a 3. I put in a 1, I put in a 1, I put in a 1. Nope, I don't see it. I don't see it. Okay. Let's go integral from 1 to 3 of x cubed minus integral from 1 to 3 of x cubed minus 4x squared plus 3 close parentheses. I got too many parentheses now. Okay, good. It says it's minus 8 2/3. So minus 8 2/3 with a minus sign. This is going to be some number around 10. Okay, so what we did is correct 8 2/3 plus 23/12 is that 10.588. So that means that our answer, this answer is right. And if that answer is right, this answer is right. But the answer is wrong. So what are we doing wrong? Okay, why don't we do something else? Fill that out. We're going to go integral from 0 to 3. 0 to 3 of x cubed minus 4 times x squared plus 3. Oh, stupid me. That's wrong. I put the whole thing in the I put the whole thing as an exponent of x. Again, 0 to 3 x cubed minus 4 x squared plus 3. Minus 6 and 7 and 7/8. Okay, so the calculus is minus 6 and 7/5. So that means there's something wrong with our formula. What's wrong with our formula? It's 3x, gentlemen. right there, 3x, 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 3x squared over 2, 3x squared over 2. That's what's wrong with our formula. So when I put in a 1, I get a 3 over 2. I get a 3 over 2. When I put in a 3, I get that, I got that. But here I get 27 over 2. Okay, so we'll get rid of this stuff. Okay, so now I've got 1/4 minus 4/3 plus 2/2. So I think that's 5/12. 5/12. Yeah, 5/12. Minus, I've got 8, no I don't. I have 81/4 minus 108/3 plus 27 over 2 minus 2 1/4 minus 5/12. Alright, so I've got 2 times 5/12 plus 2 1/4. And I get 1 1/3, 4/3. Is that what I'm supposed to get?
37/12.
Oh, 37/12.
Or 3 over 12.
Huh?
3 and 1/12.
3 1/12? Bummer.
The same as 37/12.
Okay, I did the same thing. No, I didn't. Okay, so I put a 3 in there. 3 squared is 9, 27. I put a 1 there and I get a 1. Okay, so 1/4 minus 4/3 plus 3/2. 5/12. 5/12. There's going to be 5/12 there. 81/4 minus 108/3 plus 27/2 equals, I get the same thing, 2. Yeah, but I must have done something wrong because this is a positive number. Okay, so I've got 2 times 5/4. 2 times 5/12. I got 1 here and 1 there, plus 2.25. Okay, now I got 3.083 repeating, and you say it's 3 1/12.
Yes.
1/12. Yes, that's 3 1/12. 3 1/12. I'm there. Yes, Virginia. Time to go home. Thank you.
What? Where's Paul? He'll be sitting here, and everything you say, they're like, what? I can't hear you, I can't hear you. But he hears the slightest noise outside the door, and shuts it.
Yeah.
Okay, so what you're saying is that I have to turn this around?